Why are organic molecules so stable? Organic molecules are stable mostly because, despite their huge weights, in many cases the orbital overlap that leads to these bonds are of similar if not identical, in case of carbon, in symmetry. Without going into the technical details on this with regard to group theory, I think the easiest way to describe this is as follows. Assume carbon as a tube of a finite radius x. It can form a bond with some other atom or group, say R, only and only if the radius of R is comparable to x, else the bond will be too loose to be stable. The case with organic molecules is that all associated atoms like O, N, H share similar orbital symmetry with C and hence form very stable and symmetric molecular orbitals and hence form stable compounds. This also applies to NO2, SO3H and so on, where a particular rule called hybrid shrinking or so. I am very bad at names, where the hybrid shrinks and brings about a smaller yet symmetric molecular orbital hybrid. All these lead to molecular orbitals being very symmetrical in organic molecules, and because symmetry is the first criteria for stability, it leads to the stability of such molecules. But when molecules exceed sizes of 25 to 30 carbons in a straight chain, they break and isomerize under weak energy conditions. Stability is also largely affected by electron flow in the compound, i.e. the bulk of groups and their relative electronegativities. If all these are considered, we will find several largely unstable organic molecules. Because they are not. Leave a collection of inorganic reagents for 100 years, and much of it will be still good. Do the same to a variety of organics, and most of it will turn into black tar, more or less similar to crude oil. With extreme precautions against air and light, they might do marginally better. Or look at it this way, nearly any rock out there is probably some million-year-old. Whereas the equally ancient organic stuff, there is none, except for coal, which is not quite organic, and the above-mentioned oil. Almost all organics around us, including our own bodies, is constantly destroyed and created anew. That's the very nature of it. When you look at resonance, stability is created across several atoms because the very electronegative molecules in the structure let their orbitals spread out to their neighboring molecules. If the molecule is symmetrical and demonstrates resonance, like aromatics, they share stability around the entire structure. That's one way to look at what makes things stable. In pure organic chemistry dealing with CH, both of this element hybridize to form very stable bond. They also can propagate to form long bonds also due to the stability of the CH bond.